We're going to talk about the rules for some of the trig functions. And so I'm going to start with the graph of sine. I hope that you remember that that's the graph of sine. It does keep going on forever, but I really just want to look at that one period of it. If I try to graph the derivative of sine, think about when we were graphing in the last unit how you would find the places where the slope was 0. The slope starts off positive, then it's negative, then it's positive again. And so you sort of end up with a graph that looks like this if we continue the pattern. Notice that if you start off with sine of x, then the derivative, the green graph, is cosine of x. So there's rule number 1. Alright, so let's start off with cosine x and let's see what the graph of the derivative of cosine of x would look like. Alright, again you start at places where the slope would be 0. After 0 the slope's negative, so I need to come down here. Then the slope is positive again. And then that pattern would continue. Notice that that almost looks like sine of x, except it's flipped over the y-axis, over the x-axis, I'm sorry. So the derivative of cosine is negative sine of x. So that's rule number 2. So let's look at some examples. Knowing those rules, let's look at some examples. We're going to do the chain rule, the product rule, the quotient rule, all these rules combined with the rules of sine of x and cosine of x. So on this problem, if I want to find the derivative, it's a number times sine of theta. Theta is our variable here, and in lots of cases, theta will be the variable. So the derivative, you just bring down your number and find the derivative of sine of theta, that is cosine of theta, and then you're done. Be really, really careful. If you have sine and then something, notice that that is sine of something. It does not mean sine times something, because with sine you always have to have of something. Like when you take the sine or cosine of an angle, it's always sine or cosine of an angle. It's never just sine. So there's always something that qualifies what that is the sine of, and it's never a product. So here's an example of that. There's no parentheses, but because the 3 and theta are multiplied, that means that there is a parentheses. It's just not shown. So if I want to find the derivative of this, I find the derivative of sine of the function, which is cosine of the function. But using the chain rule, I always have to go back and look at what's inside. The derivative of the 3 theta is 3, so I'll multiply that by 3. You could rewrite it as 3 cosine of 3 theta if you wanted to. Cannot multiply the 3 and the 3 because 3 theta is the qualifier of cosine. It's the part that's with cosine. Okay, another kind of problem. I want to find the derivative. So I know that we have a number and then we have cosine of something. The number just comes down. The derivative of cosine of something is negative sine of something. So that negative is going to make this be a positive. And then I multiply by the derivative of what was inside, like what was the sine of. So I'm basically looking at the derivative of 4 theta squared plus 1, where theta is the variable. And I would get 8 theta, because I multiplied the 2 and the 4 and then subtract 1. In this case, you can multiply the 8 and the 3 because they are not part of the sine. The 4 theta squared plus 1 is a part of the sine. You could also put the theta up here with the 24 just so it's not at the back, kind of in the way. Alright, so this one is basically the power rule, or at least the start of the power rule. I think that this is easier to rewrite it as cosine of x squared. Those two things do mean the same thing. Before I show you that, I want you to know that cosine of x squared is different because you're taking it of x squared. In this problem, it's cosine squared of x, and that's just 2 ways that you can write it. I like writing it this way because when I take the derivative, it's easier to see. I'm going to do the power rule. The 2 comes in front. Subtract 1 on the power. And the tricky part, which most people forget, is to always go back inside of whatever it was cosine of squared. Take the derivative of that. The derivative of cosine of x is negative sine of x, so I'm going to multiply that together. You can multiply the negative with the 2. and leave sine of x and cosine of x alone. Alright, this one, like I said, is not the same as the other. This is saying cosine of something. So to find its derivative, I find the derivative of cosine of something, which is negative sine of that thing, and then multiply by the derivative of what was inside, so I multiply by 2x. You can rewrite it as negative 2x sine of x squared. Again, I can't multiply that 2x with the x squared because the x squared is part of the sine. Alright, so we can combine other things with sine and cosine. We have e to a power. Well, the derivative of e to the power is e to the power, but then I multiply by the derivative of the power. Well, the derivative of sine of x is cosine of x. Bring down the negative, so you have this. I'm okay with that answer. The negative could come in front if you wanted it to, so it doesn't look like a minus. Be careful about that. You do need the parentheses to make sure it doesn't look like a minus. Alright, we can do the product rule. Two functions multiplied. First times the derivative of the second plus the second times the derivative of the first, which is 1. That's your answer. Nothing can combine, and you leave it. You can do the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. You can factor out a e to the x. There's nothing that will cancel though if you do that. You just leave it. Alright, tangent. So here's your another rule. In order for me to show you the rule, I'm just going to show you where it comes from. So if I have tangent of x and I want to find its derivative, I want to rewrite tangent of x as sine of x over cosine of x. That's just another rule maybe from pre-calculus that you may or may not remember, but hopefully you do. So what I'm going to do, instead of just telling you what the derivative of tangent x is, I'm going to find the derivative of sine of x over cosine of x. And I'm going to do that by using the quotient rule. So we have the bottom times the derivative of the top. Derivative of sine of x is cosine of x. Minus the top times the derivative of the bottom, which is negative sine of x, over the bottom squared. Alright, you can combine the cosines. You can combine the sines. Now, be careful here. You cannot combine or get rid of the cosine squared of x's. But there is a rule called the Pythagorean identity that cosine squared of x plus sine squared of x is 1. So this gives us 1 on the top over cosine of x squared. So the derivative of tangent of x is 1 over cosine squared of x, or x squared. Another way it could be written is secant of x squared, because 1 over cosine is secant. And I know that problem showed you a whole lot of rules to remember. You do want to remember that tangent is sine over cosine. You do want to remember that 1 over cosine is secant. You also need to remember that the derivative is 1 over cosine of x squared. Or at least remember where it comes from so that you can get the answer. Alright, here's another similar kind of problem as the tangent, except it's cosecant. And I just want to show you, like, if you see cosecant in a problem, or if you see secant in a problem, I think it's easier just to change it to sine or cosine. Tangent, easier just to use the rule, but cosecant, what I would do first is I would rewrite it as 1 over sine of x. The way I remember it is if it starts with a c, the one that it's over is s. And so also, just in case you need a reminder, secant is 1 over cosine of x. Again, look at those letters, they're opposites. That's kind of how I remember it. So if I want to find the derivative here, I could do our fancy rule that we talked about in class today, where we bring it up, make it sine of x to the negative 1. And then you could do the power rule with it. -1 times sine of x to the -2. And then multiply by the derivative of the inside, which is cosine of x. I just want to show you real quick, you can rewrite that as negative cosine of x on top with sine of x squared on the bottom. I'm okay with that answer. You never know how your answers may be presented on the AP test. I want you to realize that we could rewrite it like cosine of x over sine of x times sine of x, which is cotangent. Here's you another one. Cosine over sine is cotangent. 1 over sine is cosecant. So that's another way to write it. Normally, I'm not going to write it this way, but it is possible on the AP test you could see all kinds of answers looking that way. I would be perfectly happy with this answer, or even this answer here. I just wanted you to see where it came from, just in case they happen to write things a different way. I'm going to do one more problem. Let's say that you have tangent of 4x squared, and you want the derivative of that. Use the rule that I just told you. The derivative of tangent is 1 over cosine squared of whatever the tangent was of. And then you multiply by the derivative of the inside, so the derivative of 4x squared is 8x. And then there's your answer. You could write that as 8x over cosine squared of 4x squared. So I wanted you to know when you multiply, basically that number or variable could go on top. There's no try problems. I do want you to do your chapter 2 problems. And the back of the sheet, which has limits, which are multiple choice. Those are all due tomorrow, so make sure you get that done.